Hold up, team. Just getting a few things ready, and then we should be good to go. Level 3 calculus. Hi, Ashley, and hi, Laser. Come on, buddy. Why aren't you working? There we go. Level 3 complex numbers. That's what we're doing today. Level 3 complex numbers. What did I do? I did Cohere 2013. Alright, so we are going to do, looks like Cohere 2020. Citizen, I don't know which one did you win. Did you win the 6-7K one or the October one? Oh, that one I haven't done yet, mate. I'll probably do it this weekend sometime. Last weekend was all, actually no, I don't think it'll be even this weekend, because this weekend I'm going to be doing all level 3 streams, and that usually means I'm going to be blimmin' exhausted. Wait, have you guys got level 3 chem tomorrow? Should I not be doing calculus today? Maybe I should have checked the planner ahead. Huh? Need the calc practice. Okay, well, yep, that's fine. We'll do the calc practice. Level 3 complex. Sorry, just getting a few things set up and then we can get started. Okay, that's the next one. All right, cool. So team, what do we want to do? Shall we go through a couple of achieves just to start with, or just go straight into merits and excellence? What do you guys want to do? Thank you for clearing that. Oh, is it not there in this one? Hang on, give me just 1 second. Let me just check. Oh yeah, actually it's not in this stream. Who was it that asked? Roma, if you go to any of my recent exam papers, the OneNote link will be there. Sorry, I haven't actually pasted it on this because I think this was one of the old ones. I've just repeated it itself. All right, so let's do a couple of merits and then we'll start doing some excellence questions. Yeah. So I just need to have a look at which ones are merit here. All right, let's do a nice rearranging one to start off with. Get a new keyboard. So question 1C. So this is going to be a merit question. And there we go. We'll start off with that. Now, by the way, I got to let you guys know, this is the Cohere papers. So if it's the Cohere papers, they tend to be quite tricky. So, you know, don't get disheartened, but they're good. They're really good questions for practice for your exams. We're doing complex numbers, Kiwi Nacho. The 2 is outside of the square root of x. Sorry, yeah. No, if it's normally for square root, they wouldn't actually put 2 there at all. So, Fort Mellon, just in time. You're in time to do some practice questions. Liv, no, this would be level 3 calculus. All right, team. So I am going to do the first question here. Do we need a bit more time, or how are we going? Jed, come back on Monday. We'll do a bunch of level 1 streams. Casson, after the 15-hour playlist, it will be. What school do I work at? OJC, Ormiston Junior College. No, this is level 3, team. Maybe I need to put that somewhere as well. Where can I put it? All right, so here comes the first question, team. So what we've got is we've got to get rid of this this particular square root symbol first. So the way we're going to do that is we're going to go 2 root x minus 1. We're going to square both sides, which means we're going to end up with kind of like a quadratic equation here. So we've got 2 root x minus 1 times 2 root x minus 1 equals the square root symbol actually goes away, so you're going to end up with 2x minus 1. Once that's done, then what we're going to need to do is we're going to need to expand the brackets here. So, we're just going to do our FOIL there. So that's going to end up with 2 times 2 is 4, root x times root x is just x. Then we've got minus 2 root x minus 2 root x plus 1 equals to 2x minus 1. So at this point, what you want to do is you want to bring all the root x's together and then keep all the other elements to the other side. All right. So what we're going to do is we're going to write this as minus 4 root x plus 4x plus 1 equals 2x minus 1. Folks that are joining us, this is a level 3 calculus, complex numbers, really. What have I missed here? Have I missed something? Want to double check that I haven't missed anything here. X plus 1 equals to 2x. All right, so next I've got negative 4 root x is equal to, I've got 2x minus 4x minus 1 and minus 1 there. So I end up with negative 4 root x is equal to negative 2x minus 2. And I divide everything by negative 2 or just negative. So I can rewrite this as 4 root x is equal to 2x plus 2. And then I can rewrite this maybe 2 root x is equal to x plus 2. Once I get that, I need to square root square both sides. And so what I'm going to end up with is basically I've got 4x here equals x squared plus 4x plus 4. I feel like I've made a mistake. Actually, I know where my mistake is. That should be 1. So that's going to be 2x plus 1, and then 0 equals x squared plus 2x plus 1, and then I've got minus 4x. So 0 is equal to x squared minus 2x plus 1. 0 is equal to x minus 1 squared, and then x minus 1 equals to 0, and x is equal to 1. Level 1s would be on Monday, folks, after the calculus exam is finished. So let me put up a bunch of line numbers. Let me know if you have any questions with any particular line number. Cool. What grade is this? This would be a merit question. Definitely not an excellence. This is just a merit questions. Nah, Sri, I think it's just, I'm just showing the full working. I mean, if you can figure it out quicker, then yeah, why not? Go for it. Moses, yes, it does. Level 1 will be on Monday onwards, folks. I've got to focus on the level 3s next, and then once the level 3s are finished, we'll go to level 1s after that. All right, if we have no problems, then I can jump over to the next question. I'm just keeping an eye. Basically today, tomorrow, Saturday. And I'm thinking Sunday I might have to take time off because I don't know if I'll be awake by Sunday night, but it's worth a shot. All right, so I'm assuming we're good with this question, and I'm going to move on to the next one because there is... Yeah, all right, sweet. Let's go to the next one. You get 3 hours, Carter, for the whole exam. You don't need to, Paul. Buy something nice for your parents. Add source. We're going to need to put a text. Where can I chuck this? Then move that there. There we go. That's a... Oh my God. All right, so this question, I'm going to give you another couple of minutes and then I'll actually go through it. What's my plans after level 1 and 3 externals are over? Cassin, I'm going to make a bunch of t-shirts because I think I might actually drop a few t-shirts to go on sale. I've just had like some people really wanting one, so I was like, okay, fine. After the exams are over, I'll actually sit down and make some t-shirts. All right, I'm actually going to go through this one. So one of these things about these types of questions is like when they say show z equals 2 minus 3i as a solution, all you really have to do is just substitute 2 minus 3i wherever z is. So in this particular case, all I'm going to do is, because it's z squared, that's 2 minus 3i squared plus 2 over 2 minus 3i is equal to 11 times 2 minus 3i plus 8 over 13. Now, interestingly enough, this particular question, what you can do is, what can you do? As long as you saw the left-hand side is equal to the right-hand side, then you can eventually put that equal to each other, and then you should be fine. So there are certain parts you have to show the working. So this question, I know that you can kind of do this in the calculator, but what I would always recommend you to do is just do the steps. But I would also put these in the calculator. Now, one thing that that's worth remembering for you is that you don't want to be writing 2 minus 3i all the time. So I'm going to take something like alpha e here, and I'm going to put that as 2 minus 3i. And if I don't know if I remember this correctly, but let me just check this. I think if you do this, yeah, it's error. So that means you got to do it this way. So I'm going to go 2 minus 3i, and I want to store this as alpha e. Well, hopefully this works. Yeah, there we go. So that means anytime I click on alpha e, I'm going to end up with 2 minus 3i. So what I'm going to do is just go alpha e squared, because I don't have to type in 2 minus 3i. So that's negative 5 minus 12i. So I'm going to put negative 5 minus 12i plus 2 divided by 2 minus 3i equals, here I've got 22 minus 33i plus 8 equals to 13. And on the right hand side, I've got negative 13 minus 12i divided by 2 minus 3i equals to 30 minus 33i over 13. So now I got to rationalize the denominator. So I'm going to multiply by 2 plus 3i and 2 plus 3i. But notice I'm not actually doing the calculation. All I'm doing is I'm just showing the working, but the actual calculation, I'm doing it on the calculator itself. Did I copy that wrong? Is that supposed to be minus 5? Yeah, my bad. So that's got to be minus 5. If that's minus 5, then we've got minus 3. Is that better? Hopefully that's better. So then from this point, what we can then do is we can actually go minus. So I'm going to plus 2 this just to get rid of that as minus 3 minus 12i. And I'm going to multiply this by 2 plus 3i, which is 30 minus 3i, 33i. And then the denominator would have been alpha e, which was 2 minus 3i, multiplied by 2 plus 3i. And that's equal to 13. So what we can see is both of these answers are equal to each other. So we can say, therefore, 2 minus 3i is a solution. And because it's got a complex numbers, you can actually also say then the second solution would be 2 plus 3i. Yeah, is also a solution. Ishtoni, no, these are from like some old exam papers that I've had. Unfortunately, I can't share them. I am allowed to make videos on them, but I can't share them. Sorry, guys. Yep, you could do that as well. Pencil definitely can do cross multiplication, and as long as your final answer ends up being final answer works out to be 0, then I think it should be fine. Or you can even rearrange it as a quadratic. This particular formula here, you could arrange it, cross multiply and write it as a quadratic and solve it that way as well. Yeah, you can also use conjugate root theorem as well, Jacob, so that's all fine. I'm gonna throw it out there. Would you guys like to do a complex numbers excellence question that involves roots and solutions and long division? Yeah, Ashley, as long as the left-hand side, you've got to show the left-hand side that you're doing multiplying by the conjugate. What do you call the thing? Yeah, the conjugate of it. Otherwise, then it doesn't actually count. So you have to actually show that you're multiplying by the conjugate in the denominator to rationalize it. This would be a merit. So could I first separate 2 minus? No, then we cancel 1. No. That won't work. That won't work, citizen, because that's base. That's factors there, and it won't work like that. Sum of roots theorem could work, Jacob. You could try that if it works. Hamish, you can also do it that way. That's a second way of doing it. So you can rearrange it to make it into a quadratic, and then from the quadratic you could actually solve the 2. You can prove that the z is 2 minus 3i and 2 plus 3i. Jack, that's a school question, mate. So, right. So this, I'm going to be honest with you guys. This is quite a nasty question. Definitely giving you the heads up early. Alex, yes, it always will be. That's the conjugate root theorem there. No, Ishtoni, you can just answer the merit questions and be done and dusted with it. Yeah, there you go. Jacob's got the one. If all coefficients are real in the quadratic, then one root is one root is complex. Yeah, that's right. Jacob's got the exact words that makes sense there. All right, I'm nervous to give you folks this particular excellence question, but you know what? Let's give it a go. I'm telling you right now, you gotta do long division for this, or unless you've come up with a different method. If you Ishtoni, there's nothing wrong with you missing a couple of achieved questions, but if you get 2 M questions, you would still get an M6. That's absolutely correct. No, you don't need to get all the achieved marks before the merits. I told you this is a horrible question, especially with the long division. Dylan Ball, yes, from Monday onwards we'll do level 1. I realized that I actually put that on the tick. Yeah, I should have actually done it on this part. That's all right. I wonder if I can just add a source. Can I add text? So once you figure out the first solution, I'm going to tell you guys right now, this is going to be one of these ugliest long division questions you're ever going to see. But yeah, that's pretty much one way of doing it. Unfortunately, maybe it might not be too bad, but anyway, I'll let you guys have a go with it, but then we'll kind of see what it looks like. Yes, Mohad, kind of like that. Script settings bold. All right. I don't know where to put these things. Styles. Shadow. Ooh, that's weird. I don't even know I could do that. All right, that's fine. Sorry, I'm just messing around with this. All right, guys, look, let's actually go through this question. This is really, as I said to you, like, it was a horrible question. I thought I'll let you have a kind of play around with it. The first thing is, like, find all solutions by first showing one solution is x minus 3, right? Now, the thing is, like, there's a couple of ways of doing this. You could do this by long division, or you could also do this by, what else could you do it by? X minus x squared. What is my two solutions? Let me just check something here. One solution is 3 minus 2i. Now, if it's one solution is... Let's put that in there and see what happens, right? So if I actually take x minus... let's go x minus 3... x is equal to 3 minus 2i. Now, what I'm going to do is I'm going to just chuck it in the calculator just to see how this actually works out. So I've got 3 minus 2i, and what I'm going to do is I'm going to store it as alpha a. So that means anytime I use a, that's going to be 3 minus 2i. And then what I'm going to do is... Now we've got to show some sort of working there, Alex. So first thing I'm going to do is I'm going to go alpha a cubed to the power of 3 plus minus, oh, that's in the power, plus minus 3 plus 2i. I just want to try this first. Alpha squared or a squared. And then we've got plus 4 alpha a, that's 4x, minus 12 plus 8i. Alright, so basically what happens is that when we substitute this, this actually ends up being 0. Now, yeah, we could do that. We could do that. That's one way of trying to figure it out. But then how do you go from there? If you know a way, I would love to learn it, because I don't know which one is which one I would do it. If you tried 3 plus 2i, like let's put 3 plus 2i as a. So I'm going to put 3 plus 2i as a. So then if I go back here and I want to try that equation again, See, notice how 3 plus 2i is actually not a solution. So that's not going to work. So in this case, what you actually have is another complex number. Like, basically this is a cubic. If it's a cubic, we've got 3 brackets that's going to multiply to this particular cubic. Now, because we have 3 minus 2i, it's automatic that we think 3 plus 2i is also going to be a solution. And I just tried that and it didn't work. That basically means we've actually, so if this is root 1, then root 2 and root 3, these two are the conjugate pairs. So I've kind of got to figure out how that's going to work. Now, the idea that you've got there, Dioven, is to do something like this. Because if this is Dioven's theory, right? So we've got x minus 3 minus 2i multiplied by something, like it's x squared plus bx plus c is equal to x cubed I guess this could actually work. Dioven, I think it actually is going to work, because what's going to happen is this. He's got a pretty cool idea, and I think we don't need to use long division for this, because we could actually do this shortcut method here. Minus 12 plus 8i. Now, the reason why I'm looking at Dioven's method is because you've got x times x squared. That's going to be the x cubed. But if you look at the constants, so that's minus 3 minus 2i. And if you multiply that by c, then you are going to get this value here. Because remember, that's the last two constants by itself. Commenter, normally it would have been, but in this case 3 plus 2i didn't actually work out, so we can't say those two are 3 plus 2i is a solution. But what we can get to here is we can figure out what the c value is, because when we do negative 3 minus 2i multiplied by c, that's equal to negative 12 plus 8i. So c is just negative 12 plus 8i divided by negative 3 minus 2i. Now in this case, we're going to get c is equal to 4. Yeah, for a different set, but I think it's still a good idea to check, because sometimes you could actually end up with a situation like this where you get a complex number, but then the other two numbers might also end up being a complex number. So we figured out what the c value is, but we still need to figure out what the b value is. So to figure out what the b value, so what we need to do is, how are we going to do this? We could do it two ways. I want to figure out the b value. How can I figure out the b value? It's b, I'm looking for bx times x. So I just want to look at the coefficient of x. So if I look at the coefficient of x, that is, what do I got? I've got plus 4x, which means this multiplied by c plus this multiplied by bx is equal to 4x. I hope you guys can kind of see that. So what I can do is I can go x multiplied by c plus negative 3 minus 2i multiplied by bx is all equal to 4x. Now because c is equal to 4, we can say 4x plus negative 3 minus 2i bx is equal to 4x. But if we think about it, we don't really need to worry about the x's, right? Because the x's are all common factors, so we can get rid of all the common factors of x. This would just be 4 plus negative 3 minus 2i multiplied by b equals to 4. And if we keep rearranging this, we're going to get minus 3 minus 2i times b is equal to 4, take away 4. And so you're going to get minus 3 minus 2i times b is equal to 0. That means b is equal to 0. So our quadratic here is going to be x squared plus 4. That's the second quadratic there. That's equal to 0. So our solution is going to be x squared equals to minus 4. X squared equals positive 4i squared. And then x is equal to plus or minus 2i. And that's where your conjugate root comes from. Because one of the solutions is 2i and the other solution is minus 2i. All right, now I know I went through that very fast and I apologize about that, but do not worry. What I'm going to do is I'm going to write a bunch of line numbers and I am going to take my time explaining this to you before we actually move on to the next question. Now, if there are people on the side on the chat that understand what some of the questions are, feel free to answer it, because I think this is a really good question. It just kind of tests a lot of different things. So throw me a line number that you feel like you have problems with, and then we'll go from there. Alex Berger, if you want to do a faster method, you probably would have to do long division. Line 6, there's no imaginary part for C. No, you're right. There's no imaginary part for C, but C is a constant, right? So the orange part is the constant, which is, I've got a number. The two orange parts is the constant value, which is the value by itself. And if you look in the original equation, this is the constant. So I know that this multiplied by this should equal to that. Saffron, I always struggle with the product and sum rules, but if it works for you, you can give it a go. See if it works. OHMP, that's why in the calculator I did the 3 plus 2i just to test it, because otherwise it's very easy to assume that it's a solution and you can actually go straight into that. Yeah, JWS, I know the solver would have given you the answer, or even you could put it in you can even put it in quadratic, the cubic solver, but the problem is you have to show you're working, right? Now, commenter, I think you didn't need to show that 3 plus 2i is not a solution in this case. They just asked you to find the solution. Table, the reason why that's a conjugate pair is because one is plus 2i and the other one is minus 2i. Yeah, so I'll show you guys how to do this in the calculator. In the calculator, you would go into equation and you'd go into polynomial, which is f2. You can put degree 3 and you've got 1x cubed. Your bx squared is going to be minus 3 plus 2i. Make sure your calculator is in complex mode, otherwise this is going to happen. Shift setup, is it going to work? I think it's set up on complex mode, isn't it? Oh, maybe it doesn't understand that. How did the other person do it? Just trying to think, can you do it through cubics? Yeah, all three solutions are purely imaginary. Alex, I'll show you the marking schedule. This is the marking schedule that I got. That's it. Yes, it is, Ashley. So you can see this is the marking schedule there. That's all they've given. After long division, you get this, and then that's it. I guess I kind of skipped through that step there real quickly. Who was it that asked me? Bitty. I should have actually put that as part of the steps. I should have put 3 minus 2I subbed in and showed that it equals to 0. I kind of just skipped through that because we did a similar question like that earlier, so that's why I didn't want to do that steps again. I love it, Jacob. That's what I love about these old exam papers. They just give you like 2 steps and go, oh yeah, you do the rest of it. Yeah, I do feel, I felt sorry for the 2020 batch who did it in their mocks. I'm trying to figure out, Anish, because I thought you could, and I don't know why, for some reason, I can't. Somebody said they did it, but I don't know what they did. Because I thought if I go 1, where would I put it? Option. Oh, maybe I need to do it like this. No. Jesse, have a look at the little thing that's in the right there. There. Have a look there. How do I put not polynomial? Okay, so where do you put it then? Do you go to solver? Line 15 was just a breaker. Like you can definitely go straight from line 14 to 16. Wait, can you put this in solver and it actually works? All right, let me just try it. So you've got x to the power of 3. What is the question? Plus minus 3 plus 2i. That's going to be x squared plus 4x minus 12 plus 8i equals to 0. Dude, I'm getting a syntax error. How did you do this in solver? Might be coincidence. I get a feeling too, because yeah, and then group all the real values. Fayaz, I might actually get you to screenshot the what did you put in the calculator to send it to me, please, because I for the life of me I can't figure it out. All right, while Fayaz is doing that, I'll go see if I can find another couple of merit questions. Yeah. Find all combinations. All right, here's your next question coming up. I'm going to go do another excellence question just because the merit ones seemed fairly straightforward. It's all right. We'll figure it out. I mean, we got the next 3 days to do this, so I'll try and get in touch with Fayaz. You can email it to me later. All right, here is your next excellence question. Yeah, that's why I didn't like using the long division for Spark, because it was like trying to use long division with complex numbers is just like freaking annoying. But it does work though. And after this, we've got one locus excellence question. Synthetic division, would it work with I don't know if synthetic division, I've never played around with synthetic division. I don't know if they, if that works with using long division with complex roots though. Week begin, I've got no idea. We're just doing some random excellence questions. Just getting like, finding some old mock questions and just working on them because they tend to be quite tricky and it just makes you think differently, that's all. They're not like your standard bread and butter questions from NZQA. No, it means that A and B are not complex numbers, but that means they're either purely real or purely imaginary. That means purely real means they're just a number by itself. Purely imaginary means that they're a number and I. So something like 4i, 5i, that's purely imaginary. This is the best way to describe it. Purely real means you're going to get something plus 0i. Purely imaginary means you're going to get 0 plus whatever I. Like, so this becomes like a real number there. Well, I shouldn't maybe use the real number. It just becomes a number. I don't know. And it's really important that you guys keep an eye on this purely imaginary, purely real stuff, because every now and then you'd get a proof question and they'll say, prove this, so just on the basis that this side is purely imaginary or something like that. Now, if you're struggling with this question, team, just remember that you can actually just expand the left-hand side and then match things up, and then it'll start kind of making sense there. No, you can't say that. Expand the brackets, Ohm, and it'll start making sense. Expand a plus bi squared. So the first step I would like you guys to do is doing this part here. So do a plus bi times a plus bi first, because we're going to put that equals to minus 5 plus 12i. Yeah, I think it's some sort of equations that'll pop up. I don't know if it's simultaneous or if it's just substitution, what do you call it? Quadratic. I haven't checked it yet. We can have a look. Might just be straightforward. I don't think I can do twice the speed, man. I'm exhausted. I'm like falling asleep. It's like it's the worst time to do excellence questions when you're like half asleep. I need a coffee more than anything else. Nah, it's all good. It's all good. Jacob, you can always come back because this is going to be saved. So just come back later and then catch up with it then. Crumb, I reckon if you practice, I think you'll be all right. Did we do this question? I can't remember doing this question. Because I know actually I did like a whole bunch of random excellence questions last year. So this is excellence. We've got 2 more excellence questions and then we're done. All right, so I'm going to do this one. What we're going to do is we are going to expand the brackets. So when we expand the brackets, we're going to get a squared plus abi plus another abi plus b squared I squared. And then this is all equal to minus 5 plus 12i. Tarek and Kaif, yes, I'm live on YouTube right now. It's the same thing. Just look up infinity plus 1 and you'll find the tutorials there. All right, so what we're going to do here is we've got a squared plus 2abi. Now I squared is equal to minus 1. Because of that, I'm going to write this as minus b squared equals minus 5 plus 12i. Now, the key thing about this question is having a look at the real values and having a look at the imaginary values. So if you look at the real value, a squared is real, minus b squared is real, and on this side, minus 5 is real. And then if you look at the imaginary parts, you've got minus 2abi is equal to plus 12i. 8 p.m. Tarek and Kesha, I come back on Monday and we can go through it, but at the moment just working on level 3 calc. Nice. So with that in mind, we've got 2 simultaneous equations or something like that. We've got a squared minus b squared is equal to negative 5. We also have 2ab equals to 12. Now notice how I haven't actually written the I because, to be honest, the i's cancel out each other and I don't really care. Just looking at the coefficients of I. All right. From here, my next step would be to go, well, I can substitute something here. So I can write a is equal to 12 divided by 2b. So a is equal to 6 over b. And if that's the case, I can write 6 over b squared minus b squared is equal to negative 5. And I'm going to get 36 over b squared minus b squared is equal to minus 5. And this is super annoying, but you still, unfortunately, you still have to do it. So we're going to multiply everything by b squared. We're going to get 36 minus b to the power of 4 equals minus 5b squared. So all I did here was multiply the numerator by b squared, and b squared. So rearranging this, I'm going to get 0 is equal to b to the power of 4 minus 5b squared minus 36. So in other words, when I factorize this, I'm going to get b squared minus 9, b squared plus 4 equals to 0. So I'm kind of going to carry on here. So then I've got b squared minus 9 equals to 0. So b is equal to plus or minus 3. And if b squared plus 4 equals to 0, then b squared equals to minus 4, and b is equal to plus or minus 2i. And so I've actually figured out what all the b values are. So b is equal to positive 3, minus 3, positive 2i, and minus 2i. Now we said that a is equal to 6 over b. So this is 6 over 3, that's going to give me 2. 6 over negative 3, that's going to give me negative 2. 6 divided by 2i, that's going to give me 3i. 6 divided by negative 2i is going to give me negative 3i. So the combinations of a and b is going to be, we've got combinations of a and b. That's going to be 2 and 3. We've got negative 2, negative 3. We've got 3i and 2i, and then negative 3i and negative 2i. So those are my 4 combinations. So I'll start putting some numbers up, and then we will go through the explanations. Cool. Feel free to ask me some questions and then we'll actually go from there, all right? How do you mean, Shweta? You need to give me a line number and then I can actually go from there. Okay, sure, buddy. I can shout out your friend Avan. Shout out to friend Avan. If you use polynomial for step 13, you could use polynomial for step 13 because I think that should work. I mean, you're not getting asked to solve quadratics at, what do you call it? Let's try polynomial, degree 4. So that's going to be 1, 0, minus 5, 0, minus 36. There you go. That gives me my 4 answers there as well. So those are my answers for B. I think B, once I calculated B, Shweta, I got those 4 numbers and then I just substituted in to get A. So Vishal, I don't see why we can't use polynomial to get the 4 exact things and then go from there. Who else did I miss here? No. Yeah, that's fine as well, Diovin, if you convert it to a quadratic and solve it. But as long as you come back to the b squared, because otherwise you can get stuck with just x is equal to plus x equals to 9 or x equals to negative 4. So really important that you resub the b squared and square root the answers. Are your signs flipped for the last 2 answers? I'm trying to see where it is. Did I do that wrong? I might have done that wrong. Negative 6i squared. Sorry, that should be positive. Yeah, you're right. That's my bad. That should be negative there. Good point. So negative 3i and 2i. That should be positive 3i and negative 2i. Thank you. Apologies. Yeah, that's my bad. Just calculating things quickly. Yes, Bianca, that's your that's like kind of your standard algebra rule. So if you have like a bunch of x squareds on the left hand side and right hand side, you can put those coefficients equal to each other. So and that's what we're doing here with real and imaginary. So we're taking all the real values, putting them equal to each other, and then taking all the imaginary values and putting them equal to each other. I mean, if you look at it, like initially it kind of looked a bit weird, but then as you work through it, you kind of go, oh, yep, it kind of makes sense. Vishal, for the polynomial, you need to make sure you're using the degree 4. When you use degree 4, you got to put coefficient of b to the power of 4, which is 1. There is no b cubed, so it's going to be 0. There is a b squared, which is negative 5. There is no b by itself, so that's going to be 0. And then the constant by itself is negative 36. Am I supposed to know about level 2 English, Jay? Sugar tea, you still like, look, it's a lot of practice and these questions are like quite horrendous to some degree. All right, so last question for the night, which is one more excellence question, just a locus question, and then we'll probably call it the night after that. There we go, team. Tomorrow, Alex, we'll do differentiation tomorrow. Biti Caliphy, when they actually say fully described geometrically, all it means is that you're going to have to kind of bring it down to either a straight line, a parabola, or a circle. All right? So as long as you can get to that, you're going to be fine. So don't. At least they're giving you a clue that it's going to be one of those three things. So if you can get that formula right down to the end, you'll be good to go. Bianca, we're pretty much doing level 3 all the way through till Sunday, every night, 8 p.m. I haven't seen, I mean, like back in the day, they used to give ellipses, but now they don't do that because it can get a bit nasty with the completing the square. So generally, I've seen straight lines, I've seen parabolas, and I've seen like circles, the max. Yeah, it can be a bit annoying, Jacob. Level 1 Nico 358S, we'll be doing it from Monday onwards. Alex, this is from Cohere 2020. It's an old paper that I had copy of. You're missing something there, Orzo. Natsu, like last year I did a bunch of questions for level 3s as excellence questions. I think if you go on my OneNote, like around, as you can see, around the October, 20th October, 31st October, I was just doing excellence questions during that time. So you're more than welcome to go back to those dates and have a look at the excellence questions. And I don't think they're from exams, so they're from like different areas. Yeah, that's correct, Shaji Matthew. Yeah, you can simplify that also. All right, folks, I'm going to go through this question. So they've kind of given us a clue here, which they don't need to because we always know. And again, this is something I'd say to you. Anytime you see a locus question, just do this. Just put down x plus iy and then replace wherever there's a z with x plus iy. And let's just see what happens here. Once you pretty much get this part of it, this is not where you're going to get achieved. The achieved part is actually putting this in a modulus. So in other words, we're going to put equals to square root of two things. We're going to collect the real parts. So that's x plus n squared plus the imaginary part, which is just y squared. In this one, we're going to get x minus n squared plus y. Now get rid of the square root symbols. It's almost pointless writing them. So we're going to write this as x plus n times x plus n plus y squared equals x minus n squared times x minus n squared plus y. I'm going to stop here and I'm going to give you folks a few minutes to just kind of work this through, and I think when you get to the bottom of it, you should get an answer. Oh yeah, y squared. Sorry. Sleep. I need sleep. Jeez, you guys are brutal when it comes to if I make a mistake. Uh, 5698124. It's a junior college. Today I was teaching my year 10s. What was I teaching them? Indices. I was teaching them indices. That was good fun. Off the top of my head, Alex, no. I think usually it's your teachers that provide the practice papers. All right, I'm going to slowly expand this and kind of chip away. I got x squared plus 2xn plus n squared plus y squared equals to, I'm going to get x squared minus xn squared minus xn squared plus n to the power of 4 plus y squared. Jacob, why you gotta create stress for me, man? Cooper, I would say run some of those questions through ChatGPT or Gemini to get new questions. I've tried that and it's been all right. No, because we only take the values, Alex. We don't worry about the I there. So we just go, that y will become y squared. The x and n become x plus n squared there. All right, now what I'm going to do is I'm going to start getting rid of a few terms. So x squared and x squared disappears, y squared disappears. And I'm left over with 2xn plus n squared equals minus 2xn squared plus n to the power of 4. Now, I really don't like these things. So what can I do to get rid of this? Maybe I'll bring all the x's together, right? That might actually help. So I've got 2xn plus 2xn squared equals n to the power of 4 minus n squared. Then I can do 2x as a common factor, so that becomes n plus n squared equals n to the power of 4 minus n squared. Then 2x equals n to the, might as well factorize this. N to the power of 4 minus n squared could be written as n squared minus n and n squared plus n divided by n squared plus n. Then I can cancel these two things out and I get x is equal to n squared minus n divided by 2. Now because it's x is equal to a, remember n is a real constant, so that means x is a, when you have x equals to 3, this looks like this. So if you have x equals n squared minus n, it's just going to be a vertical line like this. All right. So no, Shady Knight, your comment is not invisible. We can see it. But we do need to say what it is. So please don't forget, part line is that you need to say that it is a vertical line between, what can we say? Halfway between n and n squared, because it's actually divided by 2. No, sorry, Alex. I didn't take square root of y squared. I actually did this. If I square both of the sides, then the square root simply disappears. Imagine it like this. If I tell you square root of x is equal to square root of 5, you would just say x is equal to 5 because both of the square root symbols disappear. That's all that happened from line 3 to line 4. The square roots disappear because you had a square root of one number equals square root of another number. That means both numbers has to equal each other. So I'm not actually square rooting y squared in that case at all. It's not wrong if you don't simplify. If you have not simplified, you still have to kind of show that it's a straight line. The x equals to 3 is just an example, sorry. Just to show you why this x, as I wanted to show you guys why this was a vertical line. So I was just kind of showing that if x equals 3, then it'll be a number. Because this is a number, it'll be a number like this, and it'll be halfway between n and n squared. That's the idea behind it. Yep, that could still work, Pink Ninja. I think as long as you can get x by itself, because that's the key thing. Not sure. 5, 6, 9, 8, 1, 2, 4. What happened in line 9? Line 9, I factorized this. So this is difference of two squares. So those two things are equal to each other. Vishal Patel, like if you don't simplify and you kind of see that from that it's a vertical line, yes, potentially it could work, but you still have to, you still have to say that it's a vertical line, because if you don't recognize it as a vertical line, then you don't actually get the E grade. You only get up to merit. Ryan, that's I don't know where I'm gonna find the time, man. Like, I don't think I'm gonna be doing distribution walkthroughs, guys, because it's just like I have to study that first, and there's a couple of things that I'm missing. That's all. Morodroxy, the reason I know it's vertical is because when we have x equals to 3, which is a number by itself, it's going to be a vertical line like this. And because this is just a number by itself, it's going to be a vertical line like this. They can, Cooper, they can use. Line 1 is given, Ashley, because it actually tells you z equals x plus iy. And we always do that with locus. Oh, line 11, sorry. Line 11, yeah, that, as I meant by, like, see, I got up to here, and I needed to kind of tell them what does this represent like in geometrically. And the example I showed you was if x was like 3, if x was a constant would always have like this. Remember, if y is equal to 3, it'll look like that. But when x equals to 3, it actually looks like this. Because this is a constant, your graph is going to look like a vertical line. So that's why I got that line 11 as a vertical line between n and n squared. What's up, Oliver? Oh, the reason it's between n and n squared is because, remember, when you want to find halfway point between two numbers, you add them. Well, you can kind of subtract them and divide it by 2. Maybe I shouldn't have said halfway. If it's n squared minus n, then that'll become so imagine if you take like why would it be n and n squared minus halfway? That's a good point. Because I think it's divided by 2. I think when two numbers, the difference between those two numbers, and you divide by 2, wouldn't you find halfway point between that? Like, I'm trying to think. If I say 7 and 3, so 7 minus 3 is 4, 2. That's going to be 2. Yeah, you're right. I don't know why I've said that. That wouldn't work. Yeah, you're right, Jacob. If it's n squared plus n, then it's halfway. But I'm just wondering, can we actually do it any other way? What would that be? Divided by 2, and then we'd have to times it by 2. What if I do n? No, hang on. That's not right. If n is 3, then n squared is 9. 9 minus 3 is 6. 6 divided by 2 is 3. Yeah, I think it should be the vertical line. What the hell? I'm messing up something here. Sorry. It can't be between n and n squared, because if n is, I don't know, 4, n squared is 16. 16 minus 4 divided by 2 is 6. So it's not halfway. It's like there's some sort of proportion to it. Because if it's 2, then it's 4, then it's 1. Yeah. No, I don't think we can actually say it's halfway. I would probably just say vertical line for now. Yeah, I was confused as well. I was like, I don't know why I decided to do that. I think I saw the n squared plus n, and I automatically assumed that it was halfway between, because normally you take two numbers, added together, divide by 2, you find midway point. Could call it that. Could call it perpendicular bisector. Yeah. Nah, Vishal. Now I've got schoolwork, man. Like, we've got prize giving coming soon, and I've got a few things that I need to do for that. Yeah, I think we can just say vertical, Moto. Look, I would actually be cheeky and just put that it is when x is equal to n squared minus n over 2, there will be a vertical line there. So I would say something like that as well. If n is 3, x is equal to 3. If n is 4, x equals to... Yeah, I think unless we find a little pattern for it, Shaji. Nah, folks, that's pretty much it for today. We will come back with... I'm going to come back with differentiation tomorrow night, and then Saturday night we'll do integration. We can just... Yeah, that's... And I know I kind of messed around with that last question. I think I might have explained that wrong, but you get the idea what I mean by the n squared minus n over 2. Yeah. It's got a perpendicular bisector, but I think the schedule is not correct, because let me just grab it. I don't agree with the recognize the vertical line halfway between n and n squared, because for that it needs to be n squared plus n over 2. Yeah, but it doesn't, BitCali, I think it doesn't work for... Yeah. NASA, no, I can't say your name. That's going to be, just jump on YouTube. You can have a look through the working and go through from there. E7, yeah, take the E7 ohm. That's the final part there. Vertical line E7. 1 point for that crazy part is a little bit too much. Yeah, it's weird it says that, but I don't know. I don't know. Maybe we're missing something. I need to have a look through that one again, Jacob. It is, yeah. It is halfway between negative n, but then you've got n squared minus n. Oh, right. I understand what you mean by halfway between n squared and negative n. That would work. Because look, actually, yeah, that makes sense. It's not between positive n. Because if you have x is equal to n squared plus negative n over 2, then you can say it's halfway between not positive n, but negative n and n squared. I think somebody had that right. Who had that? A Rosa Spark, was it? Yeah, there you go, Rosa Spark. You got your E8 after all. You could write it like that, right? Because when we do n squared plus negative n, then we can say it's between negative n and n squared. Yeah, credit to Orozo. Nice job, Orozo. Nice job. Oh, because, yeah, it was just like, what are we missing there? We could always put that as a plus. Nah, sweet. All right, team. I will see you tomorrow for differentiation. If, yeah, just see how it goes. And then I'll see you guys at 8 o'clock. I might be a little bit late because usually Fridays I sit down and play games with my kid and got to do that first before coming on stream. But once I finish doing that, so it might be 8 o'clock, it might be 8:15, but we'll most likely go a little bit late because it is Friday. You guys got no exams. We'll go late till the, till we finish a few questions for differentiation. And then we'll do the same on Saturday night for integration. We'll work late. All right, team. That's basically it from me today. Yeah, thank you so much for coming. Good luck for chemistry tomorrow. That sounds a lot of fun for a lot of you. Or accounting, whichever one you guys are going to do. At the moment, Shaji, we're playing Fall Guys. Otherwise, we also play Pokemon TCG, so... TCG is good fun because we play, you know, we've got decks and we kind of done that a lot. What is it? Zia, level 1 is going to be on, it's going to be on Monday onwards. I fully haven't looked at the level 2 papers, man. Like, honestly, I've been busy with school and a few other things. I've been busy with these guys. Been printing little, I don't know, what do you call them? Labubus. Yes, EJ, we're going to be doing tomorrow differentiation and then we'll do integration on, what do you call it? Saturday. Zia, I applied a couple of times. They rejected me. And so I was like, I can't be stuffed. Nah, don't play Clash. I don't really play it for trophies, Chief. Just me and him, we just muck around with it. Do I teach geography? No, I don't teach level 3 geography or technology. Yep. Welcome to the game, Sri. I applied a couple of years and I didn't get called back, so I was like, stuff this. Let it go, Oliver. Let it go. Citizen, I think you ask me this almost every year. Orozo, now we used to stream on this channel. And I think, why are you speaking to, Sophia, why are you speaking like as if I'm not here? Which one was it? I'm trying to think. Yeah, we've been, we were put on shelf for about a year. We're currently working on our application to come back to streaming. All depends what management at home says, but we'll work on it. Which one was it, Sophia? Because it's like I see so many on. Like sometimes I kind of go, ooh, I don't really want to see this. It's a bit disturbing. There are some disturbing TikToks out there. Savindu, no, I failed all of them. I think 101 stat I passed, but everything else I failed. Nah, some of them are funny, but some of them are like, I don't know, man. I'm a little bit freaked out about this. Hi, Shanvi. Angan Boy, go check out Mr. Weebly on YouTube. He is amazing for physics. Well, welcome back, William. 2022, eh? That was good times. I'm not sure, Savindu, whichever uni you are in. So you actually go. Yeah, you've got to figure out. Yeah. I haven't fully looked at it yet, Samar, because I like to do questions on my own before looking at other people's answers. Otherwise, I don't see the challenge. So. Was that the 8-year-old one, right? That one was fun. Yeah, I know, but like, what happens is like it's a bit weird, right? Because like I go to school and then kids will come and say something, and I'm like, oh, there's this weird person doing some random thing on YouTube for you, and I was like, okay, no, I don't want to look. I don't want to look. But then some of them, it's a bit weird, and then the kids actually talk about it, and I'm like, sometimes they show me, and I'm like, okay, that's just disturbing. But yeah, you know what? I know it's just for giggles, but I'm like, because at the end of the day, like for me, because I'm still a teacher, like like that's still my main kind of profession, right? Like, so it kind of come across a bit odd. So that's why I got to be very mindful of it. Like even here on the chat, like sometimes people will come and say something crass, and I've got to be like, cool. My mods, if, like will kick in and kind of say, right, this person's gonna kind of leave. But yeah, so I've got to be super, super careful with that. No, Holly, not this year. I've got a bunch of level ones that I need to kind of push through. Matt's my lover. No, it's not. Yeah, good luck, Angan. Hey, William, like I told Auckland Uni for so many times, it's like I would love to come and do some workshops there, just some general well-being and goal-setting workshops. And we always talk about it, but we never make it happen. And I'm like, come on, man. Like, I hear these rumors about the number of year ones talking about Infinity Plus One. I would love to come and have a yarn. Yes, Daily, I do know him. I reckon both, Citizen. Go for both. Abdi's already preparing for next year. All right, what I gotta do next? I've got to do that in gold. Nah, Ashley, I think complex numbers, if you get a couple of proof questions, you'll be fine. Because I always feel like the proof questions are the ones that matter the most. Mech engineering. Oh, God. Like, he's asking the wrong person for engineering, man. No, that one's stoofed. See, I've been making these key tags, and I got like so much different filament now. Maybe I should start making some gold ones. Gold filament key tags. There we go. There's always somebody that'll come and give you advice there, Angan. Always someone to give you some advice. On to the next project. All right. Anyway, team, look, I've got to get going. I've got to do some work and printing and a few things. Take care. Chicken nuggets. No worries, you're welcome. It's good fun as long as people are getting some useful things. That's always good. So team, I will Ronaldo and Messi. Come on, man. Look, you can't compare those two. That's like an argument that you can have forever. Because on one end you've got pure talent, on the other end you've got pure hard work. I mean, you can't compare those two. They're like two, like we're just lucky to watch those two play at this time. That's all I would say. Hooper, that's a no-brainer. You don't put that line. That's a pretty obvious one. Yeah, I think so too. I agree with Citizen. You just gotta appreciate that we're witnessing some really cool things that's happening there. But in saying that, guys, take care. I will see you tomorrow at 8 o'clock for differentiation. TikTok, I'm signing out. Any level ones that are still hanging around, remember, we'll go on Monday for level 1 and we'll just go hard Monday, Tuesday, Wednesday. All right, take care, TikTok. Till the next time, as always. Oh, wait, I got 20 seconds to go. 20 seconds to go to make that little... Do I? No, I don't. Nah, I'm good. See you later. Bye. Take a good one. All right, YouTube, I'll see you tomorrow at 8 o'clock for differentiation. Till then, take care, guys. Rest up. Good luck for all your exams tomorrow as well. Sweet. See you later. As always, thank you for watching.